hole is entering the solar system. It is not visible, it does not shine, and no telescope can capture it directly, yet its mass is already beginning to alter the motion of everything around us. From the outer regions beyond Neptune, its gravity spreads inward and subtly reshaping trajectories that have remained stable for millions of years. At this distance, nothing dramatic happens. The planets continue to orbit and the sky appears unchanged, but the structure that holds the solar system together is no longer perfectly balanced. An external force has entered the system and its influence will grow with time. The closer it moves, the faster everything breaks. The entire solar system is pushed toward a chain reaction that will end in total collapse. Its presence is the outer frontier of the solar system, a vast expanse where sunlight is weak and distances are measured in billions of kilometers. Here, beyond Neptune, the Kuiper Belt forms a diffuse halo of icy bodies, remnants from the early formation of the system that have remained largely undisturbed for billions of years. As the black hole moves through this region, its influence is no longer confined to subtle deviations. The effect becomes dynamic. Objects that once followed slow and predictable orbits begin to accelerate, their paths bending in ways that reflect the growing strength of an approaching gravitational field. At first, this transformation remains invisible to the human eye, but in simulation it becomes unmistakable. Entire populations of icy bodies are pulled out of their stable configurations. Some are deflected outward into deep space, escaping the solar system entirely. Others are drawn inward, their trajectories elongated into long elliptical paths that carry them toward the inner planets. This process is known as gravitational scattering. It does not require contact or collision. The mere passage of a massive object is enough to exchange energy with smaller bodies, altering their motion in a precise and deterministic way. What had been a stable structure becomes a region of redistribution, where trajectories are continuously reshaped by a moving source of gravity. Over time, this disruption produces a visible consequence. Comets begin to appear in increasing numbers, entering the inner solar system from directions that do not match known reservoirs. Their paths are irregular and their timing unpredictable, as if they were being released in waves from a distant and unseen origin. At the same time, a more subtle effect begins to emerge through the distortion of light itself. As background stars are observed through the region where the black hole is moving, their positions appear slightly shifted. This phenomenon, known as gravitational lensing, reveals the presence of a mass that bends the path of light as it passes nearby. The object remains invisible, yet its imprint can be detected through the way it alters what lies behind it. What makes this stage particularly difficult to grasp is the contrast between size and influence. The black hole itself, despite carrying the mass of a star, occupies a region of space that would fit within a small city. Its physical extent is negligible when compared to the scale of the solar system, yet its gravitational reach extends across vast distances, capable of affecting objects millions or even billions of kilometers away. This imbalance between compactness and influence defines the nature of the threat. The object does not need to come into contact with anything to alter the structure of the system. Its presence alone is sufficient to reorganize motion across an entire region of space. By the time these effects become clearly visible in observational data, the outer solar system is no longer a stable reservoir. It has become an active and evolving environment, shaped by the passage of an object that continues to move inward, carrying its influence toward regions where the consequences will become increasingly direct. the black hole continues its inward trajectory, it reaches the domain of the giant planets. Among them, Jupiter becomes the first major body to respond in a measurable way. Its mass dominates this region of the solar system, and its gravitational field has long acted as a stabilizing influence on surrounding objects. That stability now meets a competing force. The interaction does not take the form of a collision or a sudden encounter. It unfolds through the gradual superposition of gravitational fields. Jupiter's orbit, which has remained remarkably consistent over astronomical timescales, begins to deform under the influence of the incoming mass. The change is slight at first, a shift in velocity and a subtle alteration in trajectory, yet it marks the beginning of a larger reconfiguration. This situation can be understood as a dynamic exchange of energy between two massive bodies moving within the same system. The black hole does not need to approach closely to exert a strong effect. Its presence modifies the gravitational landscape in which Jupiter evolves, and the planet responds by adjusting its motion accordingly. Over time, this interaction can amplify, leading to increasingly pronounced deviations from its original orbit. Around Jupiter, the consequences propagate outward to its system of moons. These satellites rely on a delicate balance between their own motion and the planet's gravity. They begin to experience additional forces that disturb their stability. Orbits that were once circular or gently elliptical become more irregular. Jupiter is surrounded by more than 90 known moons, forming a vast and complex system of satellites held together by a fragile gravitational balance. As this balance breaks, some moons are thrown outward while others are pulled inward. And within this growing instability, trajectories begin to cross. When two moons collide, the energy released fragments them into countless pieces that spread across nearby orbits. These fragments become projectiles in their own right, striking other satellites, triggering new impacts, and amplifying the chaos. A chain reaction begins where each collision increases the probability of the next, turning Jupiter's once stable system into a field of cascading destruction. Entire moons can be shattered or partially destroyed, while others are violently ejected from Jupiter's gravitational hold and cast into interplanetary space, carrying with them debris that continues to propagate the instability far beyond the planet itself. What makes this stage critical is the role Jupiter plays within the broader solar system. It has long acted as a gravitational regulator, influencing the distribution of asteroids and comets and contributing to the overall stability of planetary orbits. The destruction unfolding around Jupiter does not remain contained. The debris expelled from its shattered moons spreads outward and inward, crossing orbital paths that were once cleanly separated. What begins as a localized collapse quickly propagates across the solar system, carried by countless fragments moving at extreme velocities. As Jupiter loses its stabilizing role, the delicate gravitational balance that governs planetary motion begins to unravel. The solar system is not a collection of isolated orbits. It is a tightly coupled structure where each body subtly influences the others. Once a major anchor becomes unstable, the entire system responds. Mars is among the first to show clear signs of disruption. Its orbit begins to stretch and shift, no longer following the predictable ellipse that has defined its motion for billions of years. The change is gradual at first, then accelerates as repeated gravitational interactions compound over time. Between Mars and Jupiter, the asteroid belt transforms into a zone of sustained collisions. Objects that once coexisted in relative equilibrium are forced into intersecting paths. Impacts multiply, producing clouds of debris that further increase the density of the region. Each collision feeds the next, turning the belt into a continuous cascade of fragmentation. This marks the breakdown of gravitational resonance. The subtle synchronizations that once kept orbits stable are disrupted, and motion becomes chaotic. Throughout the system, objects are no longer bound to their original paths. Some are accelerated inward toward the sun, others are flung outward into interstellar space. A growing number cross the inner solar system, increasing the likelihood of impacts with planets. At this stage, the pace of change increases noticeably. What once evolved over millions of years now unfolds over timescales that can be measured in decades or even years. The solar system enters a phase where each interaction reshapes the next, creating a feedback loop of instability. The order that defined planetary motion begins to dissolve. In its place emerges a system in transition, driven by competing gravitational forces, where collisions, ejections, and orbital shifts are no longer rare events but the dominant behavior. And beyond this growing chaos, the source of it all continues to move inward. The black hole does not remain at the outskirts. It advances, drawing closer to the inner solar system with each passing year, its gravitational influence intensifying as distance decreases. The debris, the shifting orbits, and the accelerating instability are not independent events. They are the early consequences of an object that has not yet reached its most destructive phase. As it approaches the region where the inner planets orbit, the scale of interaction will change again, becoming more immediate, more violent, and far less predictable. As the black hole continues its inward motion, it does not only disturb orbits, it begins to directly interact with the outer planets themselves. Uranus and Neptune are distant and isolated. They now lie within a region where gravitational forces are no longer gentle deviations but dominant drivers of motion. As the black hole approaches, the difference in gravitational pull across each planet becomes extreme. The side facing the black hole experiences a stronger attraction than the opposite side, stretching the planet along its axis. This process, known as tidal disruption, intensifies rapidly as distance decreases. At a critical threshold, the structural integrity of these planets begins to fail. Their atmospheres are pulled first, forming vast streams of gas that spiral toward the black hole. What was once a stable planetary envelope becomes an elongated structure stretched across space and feeding an invisible center. As the process continues, deeper layers are exposed. The planets do not explode, they are dismantled. Material is stripped away progressively, forming an accretion flow that wraps around the black hole. Fragments of ice and rock are torn apart and accelerated, joining the growing field of debris already destabilizing the system. This destruction is not instantaneous, yet it is irreversible. Entire planets are reduced to streams of matter, their mass redistributed into a chaotic structure of orbiting debris and inward spiraling material. The outer solar system loses its largest bodies, and with them, any remaining sense of stability. And as this process unfolds, the black hole continues to advance. What happens to Uranus and Neptune is not an isolated event. It is a precursor. The same forces will soon act on regions closer to the Sun, where the scale of consequences will increase even further. The black hole is now close enough to dominate the inner system locally. The scale of interaction changes from distributed instability to direct gravitational control over individual bodies. Mercury is the first to be overtaken. Its orbit tightens rapidly and becomes a spiral toward the Sun, Tidal forces increase with each pass, and the planet begins to fragment. Sections of its surface are stripped away and form a stream of material that falls inward. What remains loses structural coherence and continues to break apart under repeated stress. Venus enters a region where debris density is highest. Impacts occur continuously at high velocity, and ejecta is thrown back into surrounding space, feeding further collisions. Its atmosphere absorbs repeated energy injections and expands while the surface is resurfaced by successive impacts. The planet becomes a sustained source of fragments that contaminate nearby trajectories. The black hole's gravitational field varies strongly across short distances, which produces rapid changes in velocity and direction for any object that passes nearby. Trajectories curve sharply, and previously separated paths begin to intersect within short timescales. Close encounters between large bodies become possible. A single pass can transfer enough energy to redirect an object onto a completely different path, either sending it inward toward the sun or outward on an escape trajectory. By the end of this phase, the region between the sun and the former orbits of the terrestrial planets is filled with intersecting trajectories, high-velocity debris, and bodies undergoing continuous deflection. Earth is no longer shielded by distance or structure. It is directly exposed to both the debris field and the approaching gravitational center. By the time the disturbance reaches Earth, the change becomes immediate and violent and unfolds as a continuous sequence of impacts. Fragments from the asteroid belt and the outer system now cross Earth's orbit continuously. The sky fills with incoming objects, some small enough to burn in the atmosphere, others large enough to reach the surface. Impacts occur across oceans and continents with increasing frequency, releasing energy that reshapes entire regions. Each collision injects heat and debris into the atmosphere. Shock waves travel across the planet, triggering secondary events far beyond the initial impact zones. Oceans respond with massive displacements, generating waves that move across entire basins. The surface of the planet becomes a shifting landscape where destruction is no longer localized. The atmosphere begins to change. Dust and vapor accumulate, altering the transmission of sunlight. The sky loses its clarity, replaced by a persistent haze that reflects the ongoing bombardment. Light becomes diffused, and the boundary between day and night begins to blur under the constant influx of material. For a long time, humanity does not fully accept what is happening. The first anomalies are treated as errors, then as rare events, then as unlikely scenarios. Even as the outer planets are disrupted and distant regions collapse, there remains a hesitation to conclude that the entire system is at risk. That uncertainty disappears when the destruction becomes undeniable. The collapse around Jupiter, the dismantling of Uranus and Neptune, the distortion of Mercury, and the bombardment of Venus leave no room for interpretation. The pattern is clear, the trajectory is confirmed, and the outcome is understood. At that point, there is no longer any expectation of recovery or escape. The system is not stabilizing. It is accelerating toward a state that cannot be reversed. As the black hole draws closer, the nature of the catastrophe changes completely. Impacts continue, but they are no longer the main threat. The planet itself begins to break under the force that now dominates the system. Earth's orbit collapses into a distorted path that shifts with every pass. The pull of the black hole grows stronger than the balance that once kept the planet stable around the sun. The sky changes noticeably as the sun shifts position. The stars appear distorted, and the horizon no longer looks stable. Tidal forces rise to a level that the planet cannot withstand. The side facing the black hole is pulled harder than the rest of the Earth, and the entire structure begins to stretch. The crust fractures across continents. Entire regions collapse as the ground moves in slow and unstoppable waves. Oceans lift from their basins and shift toward the direction of the pull. Water no longer follows coastlines. It gathers into massive displacements that sweep across the surface and erase everything in their path. The atmosphere is dragged along with it, and violent winds spread across the planet at extreme speeds. At this stage, humanity understands that there is no escape. Attempts are made to leave the planet. Launches are initiated across the world, and spacecraft rise through a sky already filled with debris and distortion. But the same gravity that is tearing the Earth apart extends far beyond it. The black hole's influence traps everything within its reach. The trajectories required to escape no longer exist. The deformation of the Earth accelerates. The planet stretches further and the internal structure begins to fail. The surface breaks into massive sections that move relative to each other. The boundary between solid ground and ocean disappears as everything is pulled into a single distorted flow. In the final phase, the gravitational difference across the planet exceeds its ability to hold together. Earth is no longer a coherent body. It is pulled apart into streams of matter that extend toward the black hole. And as the last remnants of Earth are pulled away, the black hole continues its advance toward the sun, where the scale of destruction will reach its peak. The black hole reaches the central region of the solar system, and the sun becomes the next body directly affected. Before any close passage, the solar atmosphere responds to the changing gravitational field. The outer layers stretch toward the incoming mass, and large-scale flows of plasma extend far beyond their usual limits. As the distance decreases, the sun begins to lose mass in a continuous stream. Plasma is pulled away and directed toward the black hole, where it forms a rotating flow of material. This structure grows rapidly as more solar matter is captured, and the energy released during this process rises across the system. The gravitational balance that defined all planetary motion collapses at this stage. With solar mass being removed, the central field changes, and any remaining debris responds immediately. Fragments are either accelerated outward or driven inward toward the growing accretion flow. The interaction evolves into a temporary binary configuration. The black hole and the sun orbit a shared center of mass while mass transfer continues. During this phase, energy exchange intensifies, and the surrounding environment becomes highly unstable. Radiation increases and particles are accelerated across the system. This configuration cannot remain stable. As more solar material is stripped away, the sun loses the structure required to maintain its form. Large portions of its mass are removed and fed into the accretion flow, which continues to grow in density and energy output. Over time, the system becomes dominated by the black hole. The sun is progressively dismantled and reduced to streams of matter that are either absorbed or dispersed. Any remaining fragments of the solar system are subjected to repeated gravitational interactions that either eject them into interstellar space or draw them inward. The final state is not a sudden disappearance, but a transition. The original solar system no longer exists as a coherent structure. In its place remains a black hole surrounded by a sparse distribution of debris, some captured in distant unstable orbits, others expelled beyond recovery. The central star has been replaced. The gravitational center remains, but its nature has changed completely. What once sustained stable orbits and long-term structure has been reduced to a high-energy environment driven by accretion and mass redistribution. What has disappeared was never permanent. The solar system held its structure through a balance that lasted for billions of years and ended as soon as a stronger influence entered its domain. Stability existed within a narrow set of conditions, and once those conditions changed, the entire system followed. Nothing in the wider universe records this loss. There is no signal that preserves the event and no marker that distinguishes what was from what remains. The debris disperses, the energy is redistributed, and the process continues without interruption. Every trace of the Earth is gone. The planet, its history, and everything that existed on its surface are reduced to matter moving within a new gravitational structure. No fragment retains the organization that once defined it, and no remnant carries a recognizable form. Humanity existed within a brief interval defined by stable orbits, moderate temperatures, and a predictable sky. That interval closes as the system reorganizes. The conditions that allowed observation, memory, and continuity disappear, along with the structures that sustained them.